So we're asked to find the derivative of h of x. These are two distinct functions of x. You could think of this as one function of x and this is another function of x. So we use the product rule. And the product rule says you take a derivative of the first function, and the derivative of e to the x is just e to the x. So the derivative is actually 0.02 e to the x of that first function times the second function kept the same. That's plus the first function kept the same, which is coincidentally the same as the derivative, times the derivative of the second function. Right? The derivative of x to the third is 3x squared. And then you could clean it up a bit. This is 0.02 x to the third e to the x plus 3 times this is 0.06 x squared e to the x. And that's probably how I'd write it. That's the derivative. Okay, so you can use the product rule. When we first learned the product rule, it wasn't super useful because we were just dealing with polynomials. You could just distribute and avoid it, but we have to use it now. Same thing with this one. We want something about the derivative. So to find the derivative of q, we think of two distinct functions of x. And if you look up the product rule, if you can't remember it, it just says it's the derivative of the first function, which is just 7e to the x again, times the second function kept the same, plus the original first function times the derivative of the second function. And so there's your derivative. You could clean it up. That's 7e to the x over here. Okay, because the derivative of natural log of x is 1 over x. Okay, and then last one, this one, it's set up for the quotient rule. If you recall, oh wait, sorry, this isn't done, I forgot. This said at 6, so they just want you to plug in 6 into the derivative. So this is 7e to the 6 times natural log 6 plus 7e to the 6 over 6. And you could do that with your calculator. I use desmos.com/scientific for big ones like that. Okay, so we need a derivative of t of x. So this is the quotient rule because we have two distinct functions of x being divided. So it's the derivative of the first function. The derivative of e to the x is just e to the x times the second function kept the same, subtracted by the original first function times the derivative of the second function. And that's all over the bottom function squared. I think I said second function earlier, but it's the bottom function is what I mean by the second function. So there's the bottom function squared. And that's the derivative. We could clean it up like always. We could put the coefficient first in this term. I usually put the x term next, and then anything with an x in the exponent comes after. You don't have to do it that way. And then over here we have a negative times a negative, so that makes a positive. 56 x to the 6 e to the x. And that's all over negative 8 squared is 64. X to the 7th squared, that's x to the 14th. And, oh, I can't move it down. You can factor out e to the x from both these terms. You can factor out x to the 6 from both of those terms. So let's do that because it will have something that will cancel out with the bottom. Oh, we could factor out an 8 too. Let's do that while we're at it. Take an 8 out of both of them. So this is negative x to the first. This is what's left over. Then 56 divided by 8 is negative 7, right? Not negative. We took out the x to the 6. We took out the e to the x. So that's what the numerator factors to be. And then you have x to the 6th in the numerator, x to the 14th in the denominator. So those powers can subtract from one another. Remember, you just always end up with the power that's biggest. It stays there, right? Because x to the 6th divided by x to the 14th, that's x to the negative, oh, I did that wrong. That's x to the negative 8th. Sorry, and so since it's a positive, here, I'll just show you what I did over here. X to the 6th divided by x to the 14th. The power subtract to make x to the negative 8th, which is the same thing as 1 over x to the 8th. So that's why I kept x to the 8th in the denominator. And then we have 8 over 64. Those can both be divided by 8, so that can simplify. So my final answer is e to the x times, in parentheses, negative x plus 7, all over 8x to the 8th.